Keep my little shirt here. What part of this don't you understand? All right. Sorry. Okay. All right. Oh, sorry. That's illegal. I just showed pictures of students online. Sue me. Okay. Wrong class. Here is number. Shh. Number 6's work. All you had to do is slide over. Look at that first step. X squared is what you multiply x squared by to get it to be x to the fourth. But then put the x squared underneath the x squared when you distribute, and then subtract. Just nothing happens to the 3x to the third negative. So it comes down into the next step. So we just got to be able to add like terms appropriately there. And really what I wanted to start off with was good FOILers. Say it! I don't have time for this. What multiplies, because part of your skills, this is going to be huge, this chapter. The ability to factor. And those that cannot factor, you're doomed. All right. So you better do something about it in your off time. And I know in your off time, all you do is math. Right. And that's all you think about. So you might want to brush up on some stuff. Why do you have your Chromebook out there? Yeah, what's going on with that? Hey, everybody, what multiplies the 30 and adds to negative 13? 3, 2, 1, go. It's a weird one. Most people wouldn't think of negative and then wrong. We're finding zeros. What are you guys doing back here? Okay, they're sitting here jibber jabbering. Minus 10 minus 3. And then you're finding zeros, which means y is 0. Hence that's why this is x-intercepts. And that's what this is really leading to today. And that means x equals 10 is one of the solutions. X equals 3 is another, which leads to today 10, 0 and 3, 0 are x-intercepts for the graph. This people that can't factor this one, this is why you're failing CAT. All right. And I really, there's nothing I can do other than keep covering this stuff until it somehow sinks in. What's this? A difference of two. There you go. Fine. This is 0. And then recognizing that fast, that this is 2x minus 5, 2x plus 5. Okay. 2x times 2x, 5 times 5, plus minus, because good FOILers. Good factors. That gets me the negative 25 and the 4x squared, and the middle term cancels. All right. Again, not getting that. Again, and this isn't me. I have some people accusing me of being a bad teacher just last hour. This isn't me. This is what you should have mastered in Math 2 and Math 3. All right. So if we can't do that, that's from before. Oh, no. Oh, no. And then this is, if I have anyone writing this, if you write this as the factoring of this, I instantly am not giving you any credit. Instantly, because this cannot be happening anymore. What is x times x, everybody? 3, 2, 1, go. Not 5x squared. How could you possibly write that as a factorization of this scenario? At this point, it is not acceptable. All right? So what does this have to be? What times what? What do one of these have to have in front of them? To not know that is a major, 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 major problem. And we got to stop the insanity. And we got to start stepping up here and figuring out this factoring and the basis of it that I've talked about since August. Major. Well, now we got to figure out how do we get 7 in the middle with negative 6 as a product. Well, this is negative 6 as a product here. Ooh, I changed colors for some reason. So I got to get negative 6. That's negative 1 and 6, or switch the signs, or 2 and 3, one of them being negative. I feel, sorry about that. Did I hit you with that? Did I hit you in the knee? Oh, fumble. Okay, it's probably his ear, bud. All right. Oh, no, I thought it was over there. What are the numbers? I like 2 and 3. What goes with the 5x? A 2 or a 3? 3, 2, 1, go. Okay, so he says 3 and he says negative. That means a positive 2 has to go here because it's got to equal. Now, it's okay if he's wrong. It's okay if he's wrong. All right? Is that wrong? Yes or no? 3, 2, 1, go. Okay, so yes, because this is 10. He's not wrong. Boom shakalaka. That is 7x as a middle term. So I made negative 6 happen. I made 5x squared happen. I got to make 7x happen with the O and the I. This is why, whoops, that was supposed to be a pen. This is why good foilers are good factors. You're just saying the words. When you put X and X in the beginning as your final answer, it's just not happening. And I'm going to tell you right now, we've given up a little bit in CAT as far as making this factoring any bigger than numbers like 5. I mean, sometimes we put 10x squared in there. So really the undoing of this should be good enough. I'll tell you what you're doing wrong, and then when I show two methods, then people mix them up. What you learned last year possibly was this, and it's something I already showed you here. The old MA thing. What multiplies a negative 30 and what adds to 7. First of all, real quick, what are those two numbers? This is your 4-step process, by the way. What multiplies a negative 30 and adds to 7? 3, 2, 1, go. Oh no. We just had those numbers, right? 10 and negative 3, but it was 10 and 3, I think, or something like that in the previous one. So then this is what I'm getting. I'm getting someone right, x plus 10, x minus 3. You are getting 0 credit for that, none. First of all, what's x times x? X squared. What? What's 10 times negative 3? Is that negative 6? You are totally off in another world. You are stuck in a process and have no clue what factoring is, which is the reverse of FOIL. I knew something went wrong there. Okay, good. Another computer mishap. No way. And actually, when I was teaching this, I showed this ridiculousness and I said, no way. And even said that back in the day, you will be graded harshly in my class for not thinking. What those two numbers are is when you do the grouping. And then I'm going to write, what was it, 10 and negative 3? I'm going to write the negative 3 first because it's smarter. I'm not supposed to say that, but it's smarter to do that because then you have to worry about, grouping these correctly. Then you group. Now, again, this is the method that all of the math teachers are supposed to be showing as a way of going around this. The problem is I tried to wean you off of this method because I get too many people that do this. Too many. Because they think that's factoring because I followed what the teacher told me, but you only followed one of the steps. Okay, now, again, you've never seen this, so you never do this if you don't. But real quick, because I don't have much time. Completing the square has nothing to... Yeah, no, we're just no completing the square right now. Okay, so that's not completing the square. Okay, let's move on. Okay, I did want to cover one of these. I'm going to do it fast because you do not have... This is bell work. Sorry if I'm really loud and close to you guys over here. I had a computer mishap, and I get not a mishap, I have low battery on Wednesdays. Barely get a chance to plug in my computer on a Wednesday. This cannot be done by synthetic division. It's impossible. And then I'm just going to skip to the rest of our notes today, which is going to be mostly synthetic division. What time do we get out of here? Oh, wait, I got it. Don't tell me. Wednesday, 2:04. Is that right? Yes, you told me. You weren't supposed to. All right. Inside is, no, wrong. Outside is x squared minus 3x plus 5. If you can't read that, and actually that's what you should have wrote. And we're just dividing these two. We're dividing the first one divided by the second one. So the first one goes inside, second one goes outside. And then this is what I'm mostly worried about. Do I have a missing term? You should account for it just for space. But also it's a good habit for synthetic division. Fumble! All right, and then we're in the way of that poly. You know what? What am I doing? Yeehaw! Nice. Okay, everybody. What times x squared equals 3x to the fourth? 3, 2, 1, go! And I would put it over the x squared. This means I might only have 2 more steps. I could have less. It really depends. And then you distribute. Don't tell me this is difficult. It just takes time. And you got to be careful. This is what we're testing in this class. Can you be careful? Do you know x squared times x is x cubed? And that's not a negative 3. It's just I get a little pickup on my writing there. Let me erase that real quick. That's a 3x squared times x squared. And that's what you key off of, just the first term, but then you have to complete the distribution. And now I have a nice space for this. And then I subtract. And this is how I do it real quick. I just distribute the minus sign because of grade school division. You subtract this thing, and then this cancels. And now this is plus 3x cubed and negative 5x cubed. That's negative 2x cubed. This is what we're really testing. The students that say that's 2x cubed. This is why you make your mistakes. You don't have your positives and negatives down. And you got to be careful and think. I have more negatives than positives. It should be a negative answer. Did I write something wrong? Oh, yeah, right. He loves it when someone makes a mistake, by the way. It just makes his day. You're wrong. All right. Wrong. Okay. Thought I told you until you get an A triple plus, you can't be judging. Anyway. Is that correct now? Okay. All right. Now, what? I'm just leaving the highlighter yellow on that, what we're dividing by, the divisor. What times that equals the 4x cubed? 3, 2, 1, go. Okay, so what times this equals this? I'll underline. It's just 4x. These are not hard questions, meaning you don't make this challenging. And then you don't have to draw the distribution lines. It gets ugly. Distribute 4x into that polynomial. 4x times x squared. 4x times negative 3x is negative 12x squared. Better not make a mistake. Someone will pounce on it like a cat. In cat class. 4x times 5 is 20. Wrong, Mr. Samuelis. Right, and then I'll change colors again. Subtract. And then cancel. That had to happen. I could zoom this down now. So be careful here. Is that negative 3x squared? And I will just say green. I don't feel like changing. Is this negative 16x? And then this is minus 6. This should be the last step. It tells you that because you only have one more to go. And at what times x squared equals negative 3x squared? What's the answer to that? 3, 2, 1, go. Negative 3. These are not hard questions. You just got to know where to direct yourself. All right, we're halfway through class, not even, and all we've done is bell work, things that we're supposed to already know. Some key, well, this is going to be the hardest thing you have to do on your quiz coming up. Just talked with the powers that be in the other CAT classes, and we're having a quiz Tuesday on just like this will be on there, and then synthetic division things. And I kind of like it. It's a good checkpoint. Quick turnaround. You that are absent, you better be doing your stuff. When you are absent in this class, it's a destroyer to the educational process if you do nothing. This is negative 25x plus 9. Now, that is the remainder because this is, remember that long sentence that came up that took forever to be written yesterday in the notes? Anyone? Okay, when that is lower than the divisor, that is the remainder. So how do you write that? Plus, I wish I could get rid of this. Negative 25x plus 9 over what you divided by, x squared minus 3x plus 5. And the reason is grade school division. That was the first thing you learned. The divisor can be the remainder, could be put over the divisor and make it a mixed number. Not going over that again, I showed you that. And I really don't like polynomial form. My brain kind of got scattered in our meeting today. I personally, on our quiz, I'm grading it by hand. It's a written quiz. I don't care about polynomial form. I couldn't care less. Fractional form. I just really think it's a confusing factor for you. It's a confusing way of doing this. Okay, now I think I assigned 19 through 26 all. Look at what's there, 19 and 20. Okay, so anyway, sometimes I do that, and I really quick, I noticed my notes were missing something, so I needed to insert it super fast this morning. So in exercises 19 through 24, use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. Let's think of the word factor. And then and I do this all the time, but it's because it's an actual easy word that you already know. What are the factors of 12? Let's just pick a number from grade school. So here, guess who's answered first? 3. Okay, that's correct. Any other factors? 4, 6. Who else? 2. And then you always forget about these. What's missing? 1 in itself, 1 in 12. But why are these factors? Because when I divide 3 into 12, what's the remainder? 3, 2, 1, go. 0. All of these numbers divide into 12 with the remainder equal to 0. That's what the definition of a factor is. Those all divide evenly in. So for me to determine, I should only do one of these, and I only am. If I have to see if this is a factor question mark of that, then I'm just going to check through synthetic division. And what am I looking for right here? What am I looking for right here? What am I looking for right there? 0. So what do I put in this box, though, for synthetic division? For x minus 1, what goes in this box? 3, 2, 1, go. 1. And if you don't know the synthetic division process, here it is one more time. You drag this down. 1 times 1 is 1. I get it now. I get it. In regular division, we subtract. What do we do right here? 3, 2, 1, go. What do we do right here? You add. So regular division, there's that subtraction component. Synthetic division, you always add. Ruh-roh, 1 times 0 is 0. 1. Add those. And then 1 times 1 is, oh, what do we get right here? 0. So x minus 1 is a factor. That's what it means. And that's what our whole set of notes are based off of today. Getting factors. Quick question. Is that a question or a statement? I don't know what the question is. I'm sorry. You're gonna have to speak up because I moved the class, moved it back here. Okay. What? No. The remainder theorem is for synthetic substitution. Okay. Yeah. Never mind. This is a different concept than yesterday's. Okay. Different concept. Fumble. There goes a phone. How that person's gonna live without that phone now. Oh gosh. Okay, now I like this one because get your graphing calculators out. Okay, I'm gonna open up mine. But then the first couple questions are actually they're ready for you, and then that'll pop up later. It'll be ready to go. Okay, so then this is not day 1. This is day 2, and actually that was part of it. The remainder theorem. No, you got me messed up there now. The factor theorem. He got me. Okay, something is a factor of something else if the remainder is 0. Okay, that means it divides into it evenly, and we're going to build off of that. Okay, so now in this first one, this is doing the graphing calculator for you. This is the graph of this equation. Okay, so that's what I want you to understand. So then this is ultimately the big idea that we're going to hammer down in the next. There's a lot of redundancy in 2.4 and 2.5. There almost should be the same section. But then we add some components. There's some more, difficult challenges ahead. All right, so find all of the real zeros of the function. Find exact values whenever possible. Identify each, this is stupid. Identify each 0 as rational or irrational. Great. Okay, but I guess we kind of have to do that because I don't talk about those numbers anymore. Okay, so remember what I should have started the notes off with is this thing, and then we won't have time to write this. Oh, look at those notes coming up. Oh, boy. Remember this? Okay, There's a solution, a root, a zero, and then it turns into a factor. Remember, those are all synonyms, correct? Okay, because that's kind of like what I should show you right now before I go back into this, which is where am I? Is it this one? Is it this one? Oh dear. Is this the one that we did? Did I write in green and blue? Is this ours today? Yes. Okay. And then there we go. The factor theorem, not the remainder theorem. Okay. Got it. Now I'm going to zoom in on this. So I could do this. We actually have done this on the test coming up, not the quiz, the test. We actually provided pictures. And then all you had to do was analyze from the picture. So looking at this, what does it look like that zero is at? 3, 2, 1, go. What number? -3. What does it look like that zero is at? What number? 1. And then this one, that's a little bit questionable. That's in between those two. So here's how you do this. This is what your homework should be for this section. You go ahead and prove one of these two zeros. Let's start with -3. And by the way, you do synthetically divide by -3 because that is the zero. The factor that goes along with it is x plus 3, but it's -3 that you synthetically divide by. What time do we get out of here? 04, right? I think I already asked that. And then prove it. Prove the factor theorem. Prove x plus 3 would be a factor. And then eventually what happens in 2.5 is we write the polynomial in factored form from zero analysis. Okay, prove it. This should happen. Bring down to 5, -15, -22. A little nervous here to begin with. So 5, 3 to -15. I've been making mistakes today. This is 66, I believe. Correct? And that's 17. Boom shakalaka. That is -51. This is proof that this is a zero, which I could turn into a factor, which is what the factor theorem would be when we talk about factoring polynomials here. And then here's what you really should do. Write this now as a depressed polynomial and factor it. But guess what? You should know what one of the factors are. If -1 is a zero, what is absolutely one of my factors? X plus or -1? 3, 2, 1, go. Oh my gosh. If -1 is a zero, what is a factor then? X plus 1 or -1? 3, 2, 1, go. +1. No, this one, I already did the -3. Oh, it is -1. I'm sorry. I made another mistake. Go ahead. Rejoice over there. But I did say -1 is a zero. It's actually 1 is a zero. So my mistake was saying that was -1. Sorry, this is 1 is a zero. This is -3 is a zero. So if 1 is a zero, my bad, then it's x minus 1 is a factor. Then guess what? What does this have to be? X times what is 5x squared? Everyone tell me what that blank should be. 3, 2, 1, go. And if you still don't know how to tell me that, I don't know what you're doing in here. It is a very big problem. And then what times -1 equals +17? And this will all go into place here. 3, 2, 1, go. -17. And then we could check the middle term here. So I'm being harsh, but there are definite prerequisites that are missing with many people. Okay? -17x and -5x is -22. So the overall understanding of what foiling is, not stuck in a process. And then guess what my zeros are? Well, I knew one of my zeros was x equals 1. So my other zero, that one that I didn't really see very well, was 17/5. And then I could really analyze that. 17/5 is 3 2/5. That's what that is. It is between 3 and 4. I just did some grade school there, guys. 5 times 3 is 15. So this is 3 2/5 is another zero. So my zeros are x equals -3, and then 1, and then 17/5. Question? You could have, and we're going to talk about that later. But you know what? We have also made a decision at Lockport that the graphing calculator kind of eliminated the use for the P over Q list, if you know what I mean. Okay, and he's talking about something that you guys have not seen yet, unless you remember it from math 3. Okay, I got to move this so I can see the question. Now we're going to make it happen. We're actually going to go to the calculator, clear 3x cubed. Didn't I do the quadratic formula song in this class? Okay, good. We don't have to. Plus, when I have my earbuds on, oh, you're wearing earbuds, Mr. Samuelis, earphones or whatever. I can't play it and it won't work in here. I got stuck in my exponent there. 3x cubed. Can't tell me I'm going too fast. Typing really bad here. 4x squared minus 5x minus 2. So now what we're going to do is we're going to make our picture happen. We want to use the picture to extract some zeros so I know what to synthetically divide by. And that's really what we got going on with this one. So you're going to create your own picture. And guess what? You can guesstimate, graph. Oh dear. I was messing with my window with one of my periods, so I have to go zoom standard, which is 6. Boom. Hey, what does it look like that one is right there? What does it look like it crosses through? 3, 2, 1, go. -2. Fraction, possibly what other one? What's that look like? So pick one. Okay. And I think, I guess 1 probably would be the smarter of the two. It's a little bit easier to multiply and add. And then I'll use that other one to factor the remaining part of the polynomial, work with the depressed polynomial. Bring down to 3. 1 times 3 is 3, add. 1 times 7 is 7, add. Boom shakalaka. 1 times 2 is 2, add. By the by, what was my other 0 that I didn't use? What was my other 0 that I really know? -2. So what does that mean another factor of this depressed polynomial should be? X plus 2 is correct, and then you can continue the factorization, and maybe we'll get those robots that keep doing the wrong thing about writing an answer that's completely nonsensical. We'll get that out of their system. Okay, x times what equals 3x squared? What goes right in there? 3, 2, 1, go. 3x. And then what times 2 equals 2? Right there. And it is plus 1, and all I have to do is check the middle term. 1x and 6x is 7x. So there we go. So what are my zeros? Don't forget, you got 1 as a 0. That's from the graphing calculator. We knew and saw -2. Now we could see -1/3 as that other 0. That was the one that was fractionally right there, very close. So this is how you can use the calculator and synthetic division to help you get some other factors. Got to be quick, and I got to understand the question. We're running out of time. Not right now. And I told you needed to get one. So we got to move on. Okay. All right. Okay. I think hopefully something different happens with this one. Hopefully, you know what? Let's get them out of the way. Yay. All right. That's what somebody says. Okay. X cubed minus 6x squared. Huh? Ah! Just clear. Oh my goodness. You go so fast. What are you talking about? Make so many mistakes. It's all right. Minus 6x squared. Whoa, I almost hit the wrong thing there. Plus 7x plus 4. Hopefully something special happens with this one that's a little bit unique. Good. I don't know what that one is. The only one I can maybe guess is what is that right there? What do you think that is? 4. It looked like 4 to me. How many people think it was 4, right? Okay, so prove it. And then just understand the process of synthetic division. That is the 0. So that is the one I synthetically divide by. 4, 1, -6, 7, 4. Make sure you account for missing terms. Sometimes you get in the flow and you miss a missing term. All right, so be careful on that. And then I got to go fast. I see the time's waning. 4, -2, -8. Good. -1. Then 4 times -1 is -4, which is 0. Okay, then here we go. And then I think I'm going to run short. That I only have one more to go. I'll just probably have to verbalize what that one is in our 5 minutes here. Because here's what happens in this one, and this is why those other zeros are hard to see. trying to factor this. Does anything multiply to -1 and add to be -2? And the answer is absolutely positively no. So how do I get the remaining zeros? I have to do the opposite of b. Anyone want to sing? Plus or minus the square root of b squared minus 4ac all over 2a. So when it becomes not factorable, you got to find the remaining zeros by synthetic division. So that's why those two zeros, they're decimals. And I can actually prove what those decimals are after I do this. Okay, and then again, this is something that's a prerequisite skill. 4 times -4, this is actually 4 plus 4, which is 8. Square root of 8, 8 is 4 times 2. This is 2 root 2. Again, these are all skills we already covered. I don't have to break this down and teach every single thing over and over and over again until I get everyone to understand every little basic concept. And then you don't do a 6 over 5 equals 2 error. You divide everything by 2 and get 1 plus or minus root 2 as the other two zeros. Now, just for giggles, 1 plus root 2 is this one. And I'm not going to bore you with the other one. Oh, I had the calculator. That was 2.42. Look at the graph. In between 2 and 3. That's 2.42, that other zero right there. When you do 1 minus, you get that -1. All right, shoving those books away at 2:01. I got 3 minutes. Listen on this one. And probably in 3 minutes, I can do this one. I can. All right, it got in today. Nice. See, he says I can statements. Clear. 2x to the 4th, caret 4. And then you do want to pay attention to this, how to do this. And anyone that comes in tomorrow, you didn't tell me how to do this one. You're a liar and a charlatan. Whoa! Make that a squared. Holy cow. I hope this works out. Now I'm scared. All right. Minus, that's definitely not 8x cubed. That's a typo. Squared. What time is it now? Plus 14x plus 8. Okay, now I'm going to zoom out. And then hopefully I do see at least 2 zeros. Otherwise, this is definitely wrong. Hi-yo! You know what, though? I see something really bad. Let's see. You know what I have to do? I get one of these are a fraction, but we at least see one of them. What do you see? I see 4. I think another one was, I think this one's 3 halves, if I remember. So what I had to do is go to my calculator, second calculate 0. And then I want to go close to this one. I'm going to try it out. I think it's this one. Left bound. Do you ever remember doing this? And then right bound. There's another way of doing this. And then what's the 0 in between there? It's not that one, but I know what 1.41 is. I bet you it's this other one over here. Oh, sorry. So I ran out of time on this one. When I needed, listen, you're unbelievable. You are so much fun. So much fun. So much fun. Let me see. Enter and then enter. Nope, that's another decimal. So I think it's this 1/2, this -1 here. I think if you find this other 0, this one's -1/2, then I'll show you what you should have done. 4. Synthetically divide. Sorry that was a fraction, but this is going to work. And then as you walk, no collecting the homework. Get it back there. Boom, -16. Now listen, 4 times -8, 0 proof. And then I think it was a -1/2. You depress this polynomial, which is already down to an x to the 3rd. What happens when you depress that? It is now going to be a what? An x to the what? 2nd. And then you can use the quadratic formula or some other method to get it done. So you double depress an x to the 4th to get it down to an x squared. Sorry that we're out of time. Goofy questions and all. We still did pretty good.